if I want to find the integral of a function with a polynomial of degree 2 in the bottom, so a quadratic piece, and then in the top a piece that doesn't have a power of x, thank you, can you wait for me please? In the top we don't have a power of x, then what I want to do is see if I can complete the square down here. And I'll tell you why in a second, but if I had 1 power of x up here, then I might try to use a u substitution. U equals the stuff in the bottom, and then see if I can replace dx with du times some multiple of x that can handle the numerator. I don't have that power of x up there, so I'm going to go straight to trying to complete the square in the bottom. The reason I want to attempt that is because I know that if I have the integral of 1 over x squared plus 1, that's arctangent. So I want to make this look like that if possible. It's okay if it's off by a multiple, a constant multiple. So let's see what we can do. Remember, to complete the square, I'm going to take the coefficient of x, divide it by 2, and then square that. So if I divide it by 2 and then square it, I've got negative 3 squared, so that's a positive 9. And I want to put that together with the x squared piece and the x piece, but I don't actually want to change this expression, so since I added 9 in here, I'm going to subtract 9 outside of the parentheses, so that in effect I didn't change it. The advantage of this is that now I can rewrite this part as a perfect square. You can see this will be x minus 3 squared if you factor it out. And this becomes plus 25. And now this is almost like arctangent, the derivative of arctangent. If I let u equal x minus 3, then du would be equal to 1 times dx. So I could just straight up replace this dx with a du. This 25 is giving me a little bit of a headache though. So what I'm going to do is factor out this 25 from the denominator. Because I want to have a 1 here to be able to use arctangent. So when I factor out the 25, this becomes a 1. This becomes x minus 3 squared. This is in the denominator. So in the denominator, that becomes x minus 3 squared divided by 25. And instead of writing it like that, I'm going to write it as x minus 3 over 5 squared. And just notice, if you multiply this 25 back into the denominator, this definitely turns into a 25. And then in this piece, the 5 squared in the bottom will get canceled out. So it does give you back this. Now, I want to go ahead and do my u substitution. You can see it's going to be a little bit more complicated, but it's not a big deal. There's just going to be an extra constant multiple that we're going to have to keep track of. That's okay. All right, so I'll let u equal x minus 3 over 5. So du dx is, well, you can think of this as x over 5 minus 3 over 5. So the derivative is just 1 over 5. And now there are different ways to finish it up from there. If you solve for dx, you multiply both sides by dx, then multiply both sides by 5. That's what you get. So this expression becomes 1 over 25 times the integral 1 over u squared plus 1 times, and then the dx becomes 5 du. These constant multiples I'll just bring out in front and simplify. So 5 over 25 is 1/5. And then the antiderivative of 1 over u squared plus 1 with respect to u is just arctangent of u. And I'll go back and plug in what we had for u. And also write our arbitrary constant there. So this is the process. You can memorize how to go straight from the original, well, straight from here to here if you want to, or you can just factor out the 25 and use a u substitution.